FastMCP 3 implements remote sandbox execution through a provider-based abstraction layer, enabling secure, isolated code execution by delegating script evaluation to external runtime environments. This pattern leverages the SandboxProvider protocol to decouple execution logic from the core MCP server, allowing custom implementations like RemoteSandboxProvider to handle code submission and result retrieval asynchronously. We will examine how the CodeMode transform integrates with a custom Sandbox provider, configuring the MCP server to replace local execution with remote script evaluation while maintaining the standard tool discovery and invocation workflow. The setup involves instantiating the provider and passing it to the transform during server initialization, preserving the existing tool interface for clients. From collections, ABC import callable. From typing, import any. From FastMCP experimental transforms CodeMode, import CodeMode. From FastMCP experimental transforms CodeMode, import SandboxProvider. Class RemoteSandboxProvider. Async def run. Self. Code SDR. Inputs dict_str any, none equals none. External functions dict_str callable, any, none equals none. Any. Hash send code to your remote sandbox runtime. MCP equals FastMCP. Server. Transforms equals CodeMode Sandbox. Provider equals RemoteSandboxProvider. This code demonstrates implementing a custom RemoteSandboxProvider for FastMCP's CodeMode transform. The pattern shows how to replace the default sandbox execution environment with a remote service, enabling secure code execution in isolated environments. The RemoteSandboxProvider class implements the SandboxProvider protocol with a single run method that takes Python code, optional inputs, and external functions. This follows the strategy pattern, allowing different sandbox implementations to be swapped without changing the CodeMode transform itself. The provider receives external functions containing the callTool function that lets sandboxed code interact with registered tools. This approach enables important production considerations like security isolation and resource management. By implementing a remote sandbox, you can execute untrusted LLM-generated code in a separate container or service, preventing potential security risks from affecting your main application. The pattern also allows for horizontal scaling of sandbox execution across multiple machines, which is crucial when handling high volumes of code execution requests. The trade-off is increased latency from remote execution versus local sandboxing, which you'd need to consider based on your performance requirements and security needs. Let's break it down. From collections, ABC import callable. Imports the abstract base class, callable from collections. ABC, which provides a formal way to type hint functions or callable objects in Python. This enables type checkers to verify that a variable or parameter is expected to be callable, improving code clarity and static analysis. From typing, import any. Imports the any type from Python's typing module, which serves as a type hint indicating that a variable can be of any type. From FastMCP experimental transforms CodeMode, import CodeMode. Imports the CodeMode class from the FastMCP experimental transforms module, which provides functionality for modifying components in CodeMode as they flow through the server's transform pipeline. From FastMCP experimental transforms CodeMode, import SandboxProvider. Imports the SandboxProvider class from the FastMCP experimental transforms CodeMode module, which provides a sandboxed environment for executing code transformations in FastMCP. Class RemoteSandboxProvider. Declares a class named RemoteSandboxProvider that will serve as a provider in the FastMCP framework. This class will act as a source of tools, resources, or prompts, making components available to clients through the FastMCP server's provider system. The class definition itself doesn't implement any functionality yet, but establishes the structure for a provider that likely handles remote sandboxing capabilities.
Async def run
defines an asynchronous function named run that takes no parameters. The function is declared with async def, indicating it will contain asynchronous operations that can be awaited.
Inputs dict_str any none equals none
declares an optional parameter named inputs that accepts either a dictionary with string keys and values of any type, or none as a default value. This establishes a flexible input mechanism where callers can provide structured data or omit the parameter entirely.
External functions dict_str callable any none equals none
declares an optional variable named external functions that can hold either a dictionary mapping strings to callable functions or none. The dictionary keys are strings representing function names, and the values are callable objects that can accept any arguments and return any type. This variable is initialized to none by default, indicating no external functions are provided unless explicitly assigned.
MCP equals FastMCP
creates an instance of FastMCP and assigns it to the variable MCP. This initializes a new FastMCP server object that will manage component providers and handle resource discovery for clients.
Transforms equals CodeMode Sandbox Provider equals RemoteSandboxProvider
creates a list containing a single CodeMode transform instance configured with a RemoteSandboxProvider. This transform will modify components as they flow through the server, specifically using a RemoteSandboxProvider for code execution isolation. The transform's parameter is being assigned this list, indicating these transforms will be applied to components from their associated provider. The implementation showcases FastMCP3's provider-based abstraction for secure remote code execution. By implementing the SandboxProvider protocol through RemoteSandboxProvider, we decouple execution logic from the core server while maintaining the standard tool workflow. The strategy pattern enables swapping sandbox implementations without modifying the CodeMode transform itself. This approach balances security isolation with performance trade-offs. Remote execution provides stronger security and horizontal scaling, but introduces latency compared to local sandboxing. The external function's parameter preserves tool interaction capabilities, allowing sandboxed code to call registered tools through the provided callTool function. The configuration integrates seamlessly during server initialization, demonstrating how FastMCP's transform pipeline maintains clean separation between execution environments and core functionality.
The sandbox whispers secrets to functions that vanish, while the server listens for echoes it will never hear.